All right, today you're going to be working with arcs and chords. And theorem 10.2 states that in the same or congruent circles, two minor arcs are congruent. If their corresponding chords are congruent. And then just write the converse is also true. Here's what this means. If you have one circle and you have a chord right here, AB, and then another chord over here, CD. All right, in the same or congruent circles, two minor arcs are congruent if their corresponding chords are congruent. If this chord right here, if A to B is the same length as C to D, if AB, segment AB is congruent to segment CD, then arc AB is congruent to arc CD. If the two chords are congruent to each other, then these two arcs are congruent to each other. And vice versa. If arc AB is congruent to arc CD, then segment or chord AB is congruent to chord CD. So if you were given, and then, it said in one circle or in congruent circles. So if you're given two circles and you're told that the circles are congruent, oof, that's bad. All right, if you're given this picture and then you're told that NM is 2x plus 1 and PQ is 3x minus 7, and you're asked to solve for x. All right, since their corresponding arcs are congruent to each other, the chords are congruent to each other. So you just set up an equation of 2x plus 1, and you set it equal to 3x minus 7. And then you can solve for x. So subtract 2x from each side. So 1 would equal x minus 7, and then add 7 to each side. So 8 is equal to x. All right, that makes sense. If the chords are congruent, the arcs are congruent, and vice versa. Theorem 10.3. If a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. If a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. So what that looks like would be let's say you got a chord right here, chord AB. Now it says a diameter or radius because look, if you take a radius and go vertical with it right here, all right, that's a radius. But if you just extend it down to the bottom of the circle, now it's a diameter. So it doesn't matter if it's a diameter or a radius, that is perpendicular to a chord. So here's perpendicular to a chord. It intersects the chord at 90 degrees. So now you've got a radius or diameter perpendicular to a chord. It bisects the chord. So let's make this point C in here and point D and E. Here's what's true. AC will be congruent to CB. And AD, this arc AD, will be congruent to arc DB. See it? So we're going to say in circle S, the measure of arc PQR is 98 degrees. Find the measure of PQ. And you get, let's see, this picture. arc PQR, so this arc right here, is the 98 degrees. And they're asking for P to Q. So look, if this radius is perpendicular to this chord, these pieces are the same, right? And these two arcs are also the same. So if the green arc is 98, wouldn't the measure of arc PQ be equal to 1/2 of 98? Right? Because PQ and QR are congruent to each other. So half of 98 is 49. P to T. All right, from P to T. Since the radius and the chord are perpendicular, the radius bisects the chord. So P to T would be equal to 6 also. P to R. P to R would be equal to 12. All right, and let's add one more point over here. I'm going to go with M. All right, and if you had to find the measure of arc, PMR. PMR, that's a major arc. And it starts at P. It goes through M. And it ends over here at R. There's PMR. The green arc and the blue arc need to sum 360 because they complete the circle. So the blue arc would be equal to 360 minus the green arc, which was 98. So 360 minus 98. I got 262 degrees. All right, we got circle R right here. RU is a radius. And then we got this chord, TV. The chord and the arc intersect at 90. This is point S right in here. U to S is 5. And S to R is 6. And you're asked to find TV to the nearest hundredth. All right, so since this radius intersects this chord at 90 degrees, this piece is congruent to this piece. This entire radius here, right, U to R is equal to the 5 plus the 6, which is 11. So let's see how to use that. All right, you guys see this picture right here? Let me make it a little bit bigger for you. You know that this U to R is 11, and it's a radius, right? So if you connect R to T, isn't that also a radius? And if they are both a radius, then they are both 11 units long. So now you've got this little right triangle here. And in this little right triangle, if you find this one side, this T to S, all right, you can say that TS squared plus this 6 squared equals 11 squared. It's a right triangle, and you can use the Pythagorean theorem to find a missing side. So if you subtract 6 squared from each side, then TS squared equals 85. And you can find the square root of each side. So the square root of TS squared is TS, and the square root of 85 is 9.22. So this T to S represents half of T to V. All right? So if T to S is 9.22, then T to V is equal to the 9.22 times 2. So 18.44. All right, so point being, in some of these triangles, when you're asked to find the length of something that you can see, you may have to add in some other segments and use this 90-degree angle to form a right triangle, and then use the Pythagorean theorem to answer the question that's asked. All right, theorem 10.5. States that in the same circle or congruent circles, 2 chords are congruent if they are equidistant from the center. So if you've got a circle or congruent circles, if chord AB is right here and chord CD is a bad picture. Chord CD. Two chords are congruent if they are equidistant from the center. So look, when you measure the distance from a chord to the center, it goes along the portion of a radius, and it has to be perpendicular. So in both of these cases, if E to F is congruent to E to G, that means that those two chords are the same distance from the center of the circle. So you can say that if EF, segment EF is congruent to segment EG, then chord or segment AB is congruent to segment CD, and your rule about arcs is also true. Arc AB is congruent to arc CD. It's just the picture looks a little bit different because the radius doesn't go all the way through the chord sometimes. It'll stop at the chord. But if those two segments, E to F and E to G, are congruent, then the chords are the same distance from the center. If the chords are the same distance from the center, they're congruent to each other. And if two chords are congruent to each other, then their arcs are congruent to each other as well. Whose music is that? Is that music or a movie or what's going on? I don't know. I hear somebody talking or singing or. Never, huh? Probably in the other classroom. Oh, I hear her too. You hear her talking? Did you hear that movie playing? Did you hear that playing? All right, any questions on any of that we talked about today? All right, your assignment for today, page 718 and 719, 1 through 19. All right, that work, if you're in class, it's going in the basket. If you're an e-learner, you're going to email me a picture. All right, and you must show your work. If there's work for a problem involved and you just show the answer, you don't get credit for it. You got to show me what you're putting in your calculator, okay? Show your work. Show your work. All right, everybody understand what's going on? Any questions on what we talked about today? All right, e-learners, you're excused.